on lenses and mirrors are identical. So remember that. Okay, and remember the most important thing here is up here we have our formula, which you have to be clear on. The last two are only for lenses, but the crucial point is the sign convention. Okay, real image plus virtual image minus real focal point plus virtual focal point minus. Remember, a real focal point is a focal point where rays actually go through. So that's the converging lens and the concave mirror. The two with lots of cases when you're drawing array diagrams. The two with only one case drawn in the array diagram, the convex mirror and the diverging lens. Both of those have virtual focal points because the light rays don't actually go through them, as you know from your array diagrams. Okay, that's the bottom line. That's the toolbox. We move on. Converging lens of focal length 20, so you say converging, so you know that the focal length is plus 20. Has an object placed 12 centimeters in front of it, U is 12. U is always plus, object always plus. Calculate the position, which is effectively V, the magnification, which is M, and the nature is a plus or minus in the answer. That will come out from the signs from your algebra. Okay, so clearly in this case 1 over U plus 1 over V is equal to 1 over F. So 1 over 12 plus 1 over V is equal to 1 over 20. 1 over V, 1 over 20 minus 1 over 12. I consider it's a good idea to keep using your common denominators here because you need that for one or two of the more difficult questions. And we get V is minus 30 centimeters. Okay, the minus tells us that it is virtual. Okay, next step, magnification, V over U. Now, it's not in your tables, but it should be written like that. Okay, so it's minus 30 over 12, which is 2.5. It's the absolute value, you don't have to put in the minus. If you put in the minus, you won't be penalized. And remember, don't forget, that's part 1, that's part 2. There's always a risk doing an exam, and you write virtual over here, the examiner doesn't see it, so make it very clear that the examiner sees it and you say it's virtual. Okay, so second question. Calculate the position and magnification of the image formed in a convex mirror. So you say convex mirror, focal length 20, here's the key, minus 20. Okay, the object is placed 20 centimeters, U is always plus 20. In front of it. Is the image upright or inverted? We'll look at that in a second. Okay, so a position magnification, so we want V and M. So same as before. Just be careful of our minuses. So it's 1 over 20, so it's 1 over V equals 1 over minus 20. So 1 over 20 is minus 1 over 20 minus 1 over 20. Bring this guy across. 1 over V is minus 2 over 20. Don't say minus 1 over 40. Okay, so V is minus 10 centimeters. Minus indicates virtual. It also indicates one of the things we'll see in a sec. Magnification, V over U. So it's minus 10 over 20. So it's a half. Okay. Now, upright or inverted. The reality is, if you look at the array diagrams, any virtual image that is formed is upright, any real image is inverted. That's one way of remembering it. So therefore, because it's virtual, it's upright. If you aren't sure of that, just go in and draw the array diagram. Go in and draw the array diagram.